What's up, mathematicians? This is Mr. Bergman here, coming to you with section 1.6, special functions, piecewise functions, to be specific. Um, so what is a piecewise function? Piecewise function is defined kind of like this. It's got pieces, and everything in this red highlight thing is a one piece, and there are three pieces in the example piece: the top piece, the middle piece, the bottom piece. And so there's two different parts of each piece. There's the rule over here, and then there's the interval over here. So the rule is how you calculate, given any particular x value, how you calculate the y value. Very much like you've always graphed. Most functions have just one rule, and you take the x value and put it into the y value, and you use the rule to calculate the y value. But over here, you have the interval, and tells you, depending on which x value you choose, it'll tell you which rule to use. So, for example, if x is in this case, if x is equal to -5, if your x value that you're choosing equation table graph is -5, then use the top rule. If x is equal to 0, then use the middle rule. And if x is equal to +5, use the bottom rule. So here we go. Let's see what this looks like exactly. It's a little tricky, so we're going to go kind of slow. Here, this is exactly the same as in the example. We've got three pieces to this. And really what we're trying to do is you're just basically going to graph y equals 3. Like this 3 right here corresponds to the idea of the line of y equals 3. The rule says 3, and that means that doesn't matter, there's no like calculations to do. You don't have to add, subtract, multiply, or divide. The output's always going to be 3. That's what the rule says. And same thing down here. The output's always going to be -3. And when you're going to use this rule, you're going to use this rule particularly if x is less than or equal to -3. You're going to use this rule here, -2x minus 3, only when x is in between, if -3 is less than x, and which is less than or equal to +3. And you'll use this rule over down here if x is greater than 3. It's kind of tricky. Let me show you what it looks like here. But one more thing that I do want to explain before I show you the graph is this. Because this is a less than or equal to sign, then you're going to use a solid dot. And because this is a greater than sign, you're going to use an open dot, just to signify this little line right here. This little line of mine is going to make this a solid dot. And because there's no little line right here, it's going to make this an open dot, indicating that we're not really using the value of -3 here. It's just the boundary marker. So very much like if you were graphing them on a single number line that's straight across. Okay, so graphing line y equals 3 is not too bad. It's just a horizontal line at y equals +3. Except the interval says you're only going to use the part that is less than or equal to -3. So you can see we're going to need a solid dot. Another really handy rule to think about is that every one of these numbers corresponds to a dot on the graph. So this -3 and this -3 and this 3 and this 3, they're all going to correspond to dots on the graph. Sometimes open, sometimes close. So this, we're going to have a closed, filled in dot right here. Boom, you can see it goes from, it's at -3 at x equals -3, y equals +3, and then it's including all the x values that are less than -3 down here. We're going to need a table to graph this. Y equals -2x minus 3, and you notice I didn't go 0, 1, 2 from this table. I actually chose these numbers, -3 and +3, and then a number in between as well. So -3 and +3 are the x values that I'm choosing, and then -3 is going to correspond to an open dot because of this symbol right here, and +3 is going to correspond to a closed dot because of this symbol right here. You notice this is the one that has the solid line underneath. Oops. And so you can see here it's going to be a closed dot. Where is this open dot going to be? Well, it's going to be at -3, 3. As you can see, actually you can't see it. It's underneath this solid dot. And this, where's this closed dot going to be? It's going to be at 3 comma negative 9 down here. And then you can connect the dots. Notice that this 0 comma negative 3 is going to be right here. So it connects all the dots. Boom. How do you graph the green piece? Well, this negative 3 corresponds to the same idea as y, just y equals negative 3, except you're only taking values that are greater than 3. So I'm going to put an open dot right here at 3 comma negative 3, and then it's going to go it's basically a horizontal line. You can graph the entire horizontal line of negative 3, except you cut it off right here, and you only keep this, erasing the left of it right here, the left part. Some ideas to look at here is, first of all, this is not continuous. You can see you can't just draw this with one swoop of a pencil on the graph. If you had it on pencil and paper, you'd have to, you could start here, go draw this all down, and then you'd have to pick up the pencil at this break and put it back down here and keep on going. And so for that reason, it's not continuous. You could say that it's continuous just on this small little part right here, or this small part right here, but overall, on all real numbers, it's not continuous. It's also not one-to-one. It fails the horizontal line test. So you can see, you can draw a horizontal line here at this height or at this height, and it intersects more than one point. Although it does pass the vertical line test. You draw vertical lines, and there's only one point at each place, even right here. Even if you draw a vertical line, and this open dot doesn't really count for the vertical line test, but the closed dot does. So there's only one point on the function where a vertical line passes through. Next. So again, 3 pieces. You've got a top piece, a middle piece, and a bottom piece. And this top piece right here, we're going to graph using a table. And I'm going to choose only x values that are less than or equal to 0, as you can see right here. I'm going to choose multiples of 3 just because of the fraction. It'll make graphing a lot easier. And I'm going to go 0 times negative 2/3 is 0. Negative 3 times 2/3 is negative 2. And negative 6 times 2/3 is negative 4. This 0 right here corresponds to this dot. And so I'm going to, and I know it's a closed dot because of the or equal to part of this symbol. And so you can see in blue, I'm plotting these points, and at 0, 0, there's going to be a solid dot right here. Boom, solid dot, and then going in this direction, you've got the other points. Next, the middle piece. This 3, it's kind of hard to think about this 3 as a function, but it corresponds to the line y equals 3. The rule is, doesn't matter what the input is, the output's going to be 3. So that's like y equals 3. The line, graphically, the line is y equals 3. It's right here. You can imagine a really long horizontal line, y equals 3, just like you've seen before. But we're only going to consider the x values between 1 and 3. And you can see there's an or equal to symbol on both of these, so we've got the solid dots here. A solid dot at 1, 3, and a solid dot at 3, 3, as you can see right here. And connecting everything in between. Next, for the bottom piece, we're going to need a table. So we got negative 2x plus 5, and let's see, for what x values? I'm going to choose on my table, I'm not just going to go 0, 1, 2 on my table for the x values. I'm going to start at 4. I'm going to choose all values that are greater than or equal to 4, so like 4, 5, and 6. Plug them in, and I calculate these y values. And so then because of the or equal to portion of this symbol, I know it's going to be a solid dot. Where's the solid dot going to go? It's going to go at 4, negative 3. 4, negative 3 right there. And then you can see it keeps on going 5, negative 5, 5, negative 5, 6, negative 7, and it just keeps on going. Some features, some thoughts about this graph. Like the previous one, it's not continuous. You can't draw it with one swoop of your pencil. It goes here, and then you have to lift up your pencil and go here, and then continue and lift up your pencil again. So overall, it's not continuous over all real numbers. It's not one-to-one. It fails the horizontal line test. This black portion right here, because it's a horizontal line, you draw a horizontal line at a height of 3, and then all of a sudden you've got multiple points, so that's what fails. The domain is not all real numbers. There are some x values which do not produce a y value. So you can see here, because of these rules, you know what to do for most x values, but what about like 0.5, the number right in between 0 and 1? There's no rule that governs how to calculate the output. There is no outputs. And the same thing for a value of 3.5. What do you do if you're trying to calculate f of 3.5? The input of 3.5, the x value of 3.5 has no output, so therefore 3.5 should not be in the domain. And you can see that right here. You've got negative, there's 3 parts to this domain that we're looking at. Negative infinity to 0, these are all these x values. And then also 1 to 3, including 1 and including 3. And but 0.5, as I said, has no y value, so it's not in the domain. And then 3.55 is also not in the domain. So we go from 4 to infinity, including 4. Right here, you can notice the brackets. Let's take one more example. Okay, here we've got 3 pieces: a top piece, middle piece, bottom piece, blue, black, green. And I want to graph this top piece with a table because it has an algebraic rule here that I have to calculate. So, and I'm going to say I'm going to only choose x values that are less than -1, -1, -2, -3. So, plugging these in, I get 1, 2, and I'll let you figure out what that is. And then on top of it, here, because it's just x is less than -1, it's going to be an open dot right here. X is less than -1. You can see the graph. We're plotting all these points at -1, (1). We have this open dot, and then all the other points, -2, (2), -3, I don't know, get graphed right here, and you connect the dots, and that's how you get the piece. The black middle piece right here it's kind of difficult, as always. I keep on saying it, like the 0 is kind of difficult to imagine producing an entire graph, but if you think about the line y equals 0, it's a horizontal line right here along the x-axis, and you could graph the whole thing and then perhaps erase the parts you don't need. You don't need anything that's on this side of -1 or higher than +1. It's just going to be from -1 to 1 with closed dots because of the symbols. -1 to 1. You're erasing the rest. You just keep this part right here, and then we decide to make them closed dots. What about x? If x is greater than 1, so making a table, choosing only values. Okay, so I know that 1 is not greater than 1, but I'm still going to put it on my table because I want to know where this open dot goes. The open dot, same thing here. -1 is technically not less than -1, but I want to know where the open dot goes, so I'm going to put it on the table anyway. So if I put in 1, I get an output of 1. If I put in 2, output of 2. Put in 3, out. The rule is take the input and make it the output also. F of x is equal to x. So I'm going to use that information to graph this line right here. They all get plotted. 1, 1, 1, 1, 2, 2, 3, 3. Connect the dots. It goes on forever in this direction. But I'm going to make sure this 1, 1 is actually the location of an open dot because of this symbol right here. It's just greater than. It's not greater than or equal to. All right, y'all. I just want to shout out to my hometown, Philadelphia. It's where I currently live, and it's also where I was born. So when you get to that audio check, you're going to say that Mr. Bergman was born in Philadelphia. Hey y'all, funny story. I wanted to show you how to do piecewise functions on Desmos, and then I realized I forgot. And then I thought to myself, wait a minute. I was going to go through all the help session, and then I was like, wait a minute. Maybe a more valuable skill would be to show students how to find answers or how to learn how to do Desmos stuff. So when you want to do something on Desmos and you forget how, you click this button, or you don't know how, or you want to learn something new, you can press the help button. It's actually really useful. This is designed by math teachers, so it's going to be kind of streamlined and well designed. I really like these tours. There's a help center, which is good, keyboard shortcuts, which is kind of fun. But these tours are actually going to, I really like the way they're designed from an educational standpoint. So let's do restrictions today. It basically just points and tells you to do stuff, and it waits for you to do it. So like this, and then boom, it says awesome, restrict the domain of this line by adding x is less than 0. X is less than 0. Okay. And then, brilliant, create a new expression. Let's see, y equals x squared. Okay, change this equation to y equals x squared minus 2. I can do that. Now let's restrict the range and add y is less than 4 in brackets. So brackets help you add a restriction to the domain or to the range. And that's the tour. Actually, I don't want less than 4. Let's do, this is x is less than 0, so let's do x is greater than 0. X is greater than, I'm going to press the equal sign button right now to turn it into a greater than or equal to symbol, 0. And now we have something that we could see as a piecewise function. So there it is. Hope you enjoyed it. Why don't you try it out also and bring it to class.